Imagine this. A mysterious object enters our solar system moving faster than anything we've ever seen. It's not a comet. It's not an asteroid. It's something else. Astronomers scramble to study it. It spins, it accelerates, yet leaves no tail, no gas, no clue. And then, just as suddenly as it appeared, it vanishes into the dark. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But what exactly was this messenger? A wandering rock? A piece of alien technology? Or a signal that we are not alone? Today, we're uncovering everything we know about this interstellar mystery, a visitor from beyond the stars that challenged everything we thought we knew about the universe. It began, like so many stories in astronomy, with a speck of light that almost went unnoticed. On the night of October 19, 2017, atop the volcanic mountain of Haleakalā in Hawaii, the Pan-STARRS 1 telescope scanned the heavens as it did every night, searching for asteroids, comets, and anything else that might threaten or intrigue our planet. Among thousands of points of light, software flagged a faint object moving in a peculiar way. It was small, dim, and fast, so fast that within hours, astronomers realized it was unlike anything they had tracked before. Its path wasn't curved gently around the sun like an asteroid's. It was sharp, hyperbolic, an open curve that meant one thing. This object was not bound to the sun's gravity. It was just passing through. When its trajectory was plotted, excitement erupted across observatories worldwide. The orbit didn't match anything from our solar system. The object had entered from a direction roughly above the ecliptic plane, the thin, flat disk where most planets travel. It had come from the direction of the constellation Lyra, moving toward the sun at an incredible 87 kilometers per second, faster than any known comet or asteroid. As it swung around the sun and shot back toward the outer solar system, astronomers realized this was history unfolding in real time. For the first time ever, humanity was witnessing an interstellar visitor, an object born around another star, now gliding through our celestial backyard. At first, scientists didn't know what to call it. The discovery was so unexpected that even the classification systems had to catch up. For a few days, it carried the dull technical name C 2017 U1, implying it might be a comet. But follow-up observations showed no sign of a coma or tail the signature of outgassing ice. It wasn't behaving like a comet at all. It seemed rocky, dry, and silent. So its designation was changed to A 2017 U1, identifying it as an asteroid. Yet even that didn't fit perfectly. It was neither comet nor asteroid, at least not in the sense we understood them. So the International Astronomical Union introduced a new category altogether, I for interstellar object, and renamed it one ʻOumuamua, meaning a messenger from afar arriving first. That name came from the Hawaiian language, chosen to honor the telescope that first glimpsed it, and it couldn't have been more fitting. For billions of years, our solar system had existed in isolation, its asteroids and comets orbiting quietly under the sun's watchful eye. But Oumuamua broke that silence, a visitor from beyond, a cosmic wanderer whose journey likely began hundreds of millions, maybe even billions of years ago, around a distant star. Somewhere in the galaxy, a world was struck or torn apart, and a tiny shard of its remains was hurled into interstellar space. After traveling through the dark void for eons, it drifted into our solar system by chance, a grain of cosmic history passing within reach of our telescopes for only a brief moment. The discovery set off a frenzy of observations. Telescopes across Earth and in orbit turned toward this mysterious traveler. Each night mattered because Oumuamua was already racing away, growing dimmer by the hour. Within weeks, astronomers from observatories in Hawaii, Chile, Spain, and Arizona coordinated around the clock, capturing every bit of light they could before it disappeared forever. Data poured in measurements of its brightness, color, motion, and rotation. Each new finding only deepened the mystery. It was small, perhaps a few hundred meters long, but strangely reflective, quickly tumbling rather than rotating smoothly, as if it had been tossed into space like a stick caught in the wind. No one had ever seen anything like it. This was not merely a discovery, it was a cosmic event. Humanity had, for the first time, confirmed that material from another star system could cross the immense distances of space and enter our own. Oumuamua wasn't just a rock, it was a messenger from the galactic beyond, a hint of the countless worlds that exist outside our sun's reach. For astronomers, it was proof that the galaxy is not empty but alive with fragments, debris, and perhaps stories drifting between the stars. When the first images of Oumuamua were processed, they revealed something that stunned scientists. Instead of appearing as a single steady glow like most asteroids, its brightness fluctuated dramatically, sometimes as much as 10 times within just a few hours. To an astronomer, that meant one thing. This object wasn't round. It was long, very long. As it rotated, its elongated body reflected sunlight differently, creating flashes of brightness followed by deep fades. That pattern, repeated over and over, hinted at a shape that was unlike any natural body ever observed in our solar system. Calculations began. If its light curve changed that much, the object had to be at least 5 to 10 times longer than it was wide. That gave it a form roughly like a cigar or needle, somewhere between 100 to 400 meters long, spinning end over end every 7 to 8 hours. Others disagreed, suggesting the brightness could also come from a flat, disc-like shape, something like a pancake, thin and broad, tumbling as it moved. Either way, one fact was undeniable. It was extremely slender. Nothing in our solar system shared such proportions. Even the most oddly shaped asteroids like Haleakalā or Eros were stubby in comparison. Oumuamua's body seemed sculpted by forces we had never seen before. As astronomers studied it further, they noticed its color a deep reddish hue. This suggested that its surface was coated in organic-rich dust, baked for millions of years by cosmic radiation in interstellar space. That was consistent with what we knew of outer solar system bodies, like Pluto or certain Kuiper Belt objects, which develop similar colors when bombarded by ultraviolet light. But that's where the similarities ended. The way Oumuamua moved its tumbling, chaotic rotation hinted that it had been through a violent history, perhaps struck by another body or torn apart before being ejected into space. Then came the biggest surprise. As it drifted away from the sun, something unexpected happened. Oumuamua began to accelerate. Tiny changes in its velocity were measured small but undeniable. It was being pushed by some force. Under normal circumstances, this could be explained easily. Comets accelerate as sunlight heats their icy surfaces, causing jets of gas to erupt and propel them like miniature rockets. But this time, telescopes saw no visible jets, no coma, and no tail, nothing that would explain the boost. The object was accelerating as if propelled, yet it was perfectly silent, leaving no trail behind. That made Oumuamua a complete paradox. Its motion resembled a comet, yet its appearance and lack of gas made it more like an asteroid. It was something entirely new, an object that didn't fit any existing category. To the scientific community, that was both thrilling and deeply unsettling. Nature doesn't usually break its own rules, unless we've misunderstood the rules all along. As the data poured in, models were built to simulate its behavior. Some researchers proposed that its acceleration could be caused by outgassing too faint to detect, perhaps from hidden ice beneath the surface. Others argued that its shape itself, flat and broad, might allow solar radiation pressure to gently push it, like wind catching a sail. That idea, while speculative, would later ignite one of the most controversial debates in modern astronomy. But in late 2017, all anyone knew for certain was that something truly strange had just crossed our cosmic doorstep. A traveler with an impossible shape, no tail, no trace, and a motion that defied expectations. For centuries, humans had studied the comets and asteroids of our own system, believing we understood how they behaved. But Oumuamua seemed to whisper a quiet truth through the cold of space. There are still things out there that obey laws we do not yet comprehend. In the weeks that followed, astronomers raced against time. Each night, the visitor grew dimmer, fading as it rushed toward the edge of our reach. Every telescope capable of tracking it was pointed skyward, gathering the last precious data before it vanished into darkness. The clock was ticking, and humanity had only a few short weeks to uncover the nature of the first interstellar object ever seen. Yet, the more we learned, the deeper the mystery became. What was this slender wanderer? Where had it come from? And perhaps the most haunting question of all, was it truly a natural object or something else entirely? As the days passed and the data came in, the world's best minds tried to explain what Oumuamua could be. Every telescope from Hawaii to Chile, from Arizona to space observatories, was turned toward this mysterious traveler. Yet with each observation, the mystery deepened. The scientific community began dividing into camps, each with their own theory, each trying to fit the puzzle pieces together before Oumuamua disappeared forever. The first theory seemed the most natural. Perhaps it was a fragment from another star system, torn apart when planets collided. If a massive impact occurred near a distant sun, it could send debris hurtling into interstellar space. After traveling for millions of years, one such shard could have wandered across the Milky Way and ended up here. That explanation made sense, at least at first. But then came the questions. Why was it so elongated? Why didn't it show any ice or dust on its surface, despite being from a region likely filled with icy material? And how could it have survived the harsh radiation of space for so long without disintegrating? The numbers didn't add up. Others proposed it was a frozen hydrogen iceberg made entirely of solid hydrogen. That idea was intriguing. If it was hydrogen, sunlight would instantly sublimate its surface, creating an invisible jet strong enough to explain the mysterious acceleration. The problem? Hydrogen ice is so fragile it couldn't survive even a fraction of the journey across interstellar space. It would have evaporated long before reaching our Sunday. That theory quickly began to crumble. Another group suggested nitrogen ice, similar to the surface of Pluto. A chunk of frozen nitrogen blasted off from the surface of a distant exoplanet could, in theory, explain the object's color, shape, and faint push from sunlight. But again, simulations showed the odds were microscopic. For one to reach us, billions of such fragments would have to exist, and yet we'd seen only one. Then came the boldest hypothesis of all. What if it wasn't natural at all? In late 2018, a Harvard astronomer named Avi Loeb made headlines when he proposed that Oumuamua could be a piece of alien technology. Not a spaceship, but perhaps a light sail, a thin, wide structure designed to travel through space using radiation pressure from stars. The acceleration matched perfectly with how a light sail would behave if it were reflecting sunlight. Its flat, disc-like shape fit the idea too. To Loeb, the simplest explanation was that Oumuamua was an artificial construct, drifting silently through space, either as a probe or as debris from an ancient civilization. The idea sparked controversy. Some called it imaginative, others said it was reckless speculation. But for millions of people around the world, it captured something powerful, a sense of wonder. What if, for the first time in human history, we had been visited by something not made by nature? What if, somewhere out there, an intelligent species had sent it long ago, never knowing it would one day pass by a tiny blue world orbiting an average star? Scientists debated fiercely. Many defended natural explanations, arguing extraordinary claims need extraordinary evidence. Others reminded everyone that absence of proof is not proof of absence. In truth, both sides were united by the same emotion, awe. Because regardless of what Oumuamua really was, it proved that the universe is far from quiet. Objects do travel between stars. And that means the space between worlds. The dark ocean of interstellar space is not empty at all, but alive with cosmic wanderers we've only just begun to notice. As the discussions grew, the world's eyes stayed fixed on the fading light of Oumuamua. Each night, its brightness dimmed a little more as it sailed beyond our instrument's reach. Humanity had caught only a brief glimpse of it, barely a few weeks of observation, and then it was gone, leaving behind nothing but data, debates, and a lingering feeling that we had just witnessed something extraordinary. But even as it vanished, one thing became certain. This wasn't the end of the story. Because if one interstellar object had passed through our solar system, there must be others. And next time, we might be ready. After Oumuamua's mysterious departure, astronomers around the globe began preparing for the next encounter. It was clear now that space between stars isn't empty. It's filled with travelers. And in 2019, just 2 years later, that truth was confirmed when another object appeared. Comet Borisov, the second known interstellar visitor. Unlike Oumuamua, Borisov behaved exactly as expected a classic comet, complete with a tail releasing gas and dust as it approached the sunday. It was the cosmic confirmation everyone needed. Interstellar objects truly do pass through our solar system, and we were just beginning to detect them. But while Borisov's behavior was predictable, it also made Oumuamua's strangeness stand out even more. Why did the first interstellar object behave so differently from the second? Why was one a typical comet and the other a shape-shifting enigma? Those questions fueled a new wave of research. Teams at NASA, the European Space Agency, and other institutions began designing missions to intercept the next interstellar visitor projects like the proposed Comet Interceptor, which will sit in space, waiting to launch toward any new object that enters our solar system. If Oumuamua's successor arrives, humanity intends to meet it face to face. The mystery also reshaped our imagination. Artists, writers, and scientists alike began to wonder, if Oumuamua was artificial, what story could it tell? Was it a relic from a long-lost civilization, drifting through space for eons? Or was it merely a shard of cosmic rock, made special only by our brief encounter with it? The truth may remain hidden forever, but its legacy is undeniable. It reminded us how small, curious, and unprepared we still are in the vast cosmic sea. As it now travels silently between the stars, Oumuamua carries with it the unanswered questions of an entire species. It's expected to leave our solar neighborhood entirely within the next few decades, heading toward the constellation Pegasus. No probe can catch it, no telescope can follow it, it's beyond our reach. Yet, its brief visit changed how we see the universe. It showed us that our solar system isn't isolated. It's part of a galactic highway where objects and perhaps even technologies can pass from one world to another. It hinted that other civilizations, if they exist, might send their own messengers across the stars. And it reminded us that discovery often begins with mystery. So, what was Oumuamua? A natural rock? A frozen fragment? A light sail from an ancient world? No one truly knows. But one thing is certain. In 2017, humanity witnessed a visitor from the stars, and for the first time, the stars seemed a little closer. As centuries pass, Oumuamua will continue its silent voyage through the galaxy untouched, unseen, and free. Long after our cities fade and our satellites fall silent, it will still be out there, carrying the memory of its brief encounter with Earth. Somewhere in the endless void, it may drift past another sun, another world, and spark the same wonder it once did here. It's a reminder that discovery has no end, only new beginnings. Because every traveler, no matter how far it goes, leaves behind a story, and ours has just begun. Oumuamua didn't just give us an interstellar visitor, it gave us a new perspective. It reminded us that our sky is still full of mysteries, and that every speck of light out there might hold a story waiting to be discovered. Maybe somewhere in the vast silence, other eyes are watching us too, just as we once watched that lonely traveler who came and never returned. If you enjoy stories like this where science meets wonder, make sure to like the video, subscribe to the channel, and turn on the notifications so you don't miss the next journey beyond the stars. Because the universe is still speaking, and you'll want to be here when it speaks again.